Welcome to Industrial Air Filtration Basics Dust 101, brought to you by Donaldson Filters. I recently accepted a position in the industrial air filtration business, and I'm not completely familiar with what it is.
Great idea to clarify. In basic terms, industrial air filtration is this: use of a dust collector to improve air quality in industrial settings such as plants, manufacturing processes, or machining. Industrial air filtration removes contaminant from the air and environment. The basic formula of dust collection equals capture, convey, collect.
Capture, convey, collect. Can you explain further?
First, the contaminant must be captured. This is accomplished by the fan pulling the contaminant into the capture hood at its point of generation. Second, the contaminant must be conveyed. This is done via a duct system, properly sized to maintain a consistent minimum air velocity required to keep the dust in suspension for transport to the collection device. Finally, the contaminant is collected. This is done via a variety of devices, depending on the application and the contaminant being handled.
Collecting contaminant in a manufacturing facility? Why is that important?
There are many different reasons why it's important. Here are just a few. OSHA sets employee exposure standards for many workplace contaminants. United States EPA guidelines. Manufacturing facilities are required by law to limit emissions to a certain level. Levels vary depending on the state. Clean air enhances product quality by keeping particulate out of paint and maintaining visual clarity for the workers. Combustible dust concerns. Dust collectors are often a part of a customer's strategy in controlling and managing combustible dust.
That makes sense. I hadn't thought about those things. Okay, now I understand why it's so important. What are some of the common industries where you might see it?
There are many. It's really everywhere. Here's a list of the more common industries.
Abrasive blasting, buffing and polishing, cement,
food, foundries, grain, agriculture, and feed,
laser and plasma, mining, mist,
pharmaceutical, powder coating, seed,
thermal spray, welding, and woodworking. It's important. It's everywhere. But how is it done?
Well, first off, contaminants are treated through a manufacturing process like those on the previous slide. The dirty air is drawn to the collector using a fan. Dirty air is drawn through the filters where the contaminant is captured. Clean air leaves the collector and is brought back to the plant or atmosphere. When the filters are clean, contaminants are dropped into a collection bin, conveyor, or back into the process.
What are the different cleaning mechanisms used in the industrial air filtration industry?
There are 4 main types of cleaning used with Donaldson Filters collectors.
Pulse cleaning. This is generally accomplished using compressed air precisely delivered for maximum cleaning and efficiency.
Shaker cleaning. When the blower motor on the collector is off, the filter bags are cleaned using a shaking motion, either automatically or manually, such as using a foot or hand pedal.
Draining. Commonly seen in mist collection, the water, oil, or oily smoke is drained from the collector and into a collection point.
Mechanical separation. This cleaning mechanism is often seen as a pre-cleaner to knock down and collect large contaminant prior to it being collected in the primary dust collector.
This information has been very helpful. When purchasing equipment, what should a customer consider in the selection process?
There are many things to consider. Here are 4 main priorities we hear from buyers all around the world.
Footprint. Smaller is almost always better. Filter life. The fewer the filter changes, the better from a maintenance and cost-saving perspective. Filtration efficiency. Clean air for the workers and the environment. Energy consumption and savings.
Other important items to consider in the selection process are: how is the contaminant generated? What is the required airflow to control the contaminant?
consideration of the process conditions such as temperature, dust density, how much dust is being generated, is there moisture or oil present, the operational hours, and is the dust combustible or toxic?
Also, your customer may need to consider purchasing accessories like controls, discharge, ducting, fans, and/or valves.
How do the filters remove particulate from the airstream?
Great question. Many people think of filtration as the particulate being too big to get through the holes in the filter. That's true for particles that are larger than 10 micron. When the particles are smaller than 10 micron, there are other filtration mechanisms removing particulate from the airstream.
A colleague mentioned filtration mechanisms. What does that mean?
A filtration mechanism is a description of how particulate is collected. The primary filtration mechanisms are sieving, interception, inertial impaction, and diffusion. Let me provide more detail. Sieving is a predominant filtration mechanism collecting larger particulate, greater than 10 micron. Sieving occurs when the particle is physically too large to fit between two or more fibers. For example, sieving is what stops a flying insect from going through a window screen.
Interception is the predominant filtration mechanism collecting 0.1 to 1 micron size particulate. Interception occurs when a particulate comes close enough to a fiber to adhere to it.
Inertial impaction is a predominant filtration mechanism collecting 0.4 to 1 micron size particulate. Inertial impaction occurs as the airstream is displaced by the media fiber when the dust particle continues on its original course because of its mass. It's similar to a bug hitting the windshield. The bug is heavy enough not to follow the airstream over the top of the car.
Diffusion is the predominant filtration mechanism collecting very fine particulate, less than 0.1 micron in size. Because the dust particles are so fine, they are influenced by atomic forces which cause the particulate to move in the same general direction as the airstream and yet move independent of it. Think of a neighbor grilling outdoors against the wind. Can you show me what you mean in a big picture format?
Of course, check out the chart and description below. This media model graphic of efficiency versus particle size depicts how each filtration mechanism comes in and out of contribution to the overall filtration efficiency.
The top gray line is the total efficiency curve.
The navy blue line shows the contribution of diffusion. Notice the significant contribution when the particle size is less than 0.2 micron.
The brown line shows the contribution of inertial impaction. Notice the significant contribution when the particle size is greater than 0.4 micron.
The black line shows the contribution of interception. Notice the significant contribution when the particle size is more than 0.2 micron.
The orange line shows the contribution of sieving. Notice the lack of major significance with submicron particles. Interesting. What are the particle sizes again?
This chart shows relative sizes of common materials. Based on this chart, carbon black would be filtered primarily by diffusion, while larger dust such as sand, mist, or fertilizer will be filtered by other filtration mechanisms. With a barrier filtration collector such as turret, cartridge power core, or baghouse units, we need to look closely at the particle being collected. The most common dust characteristics, which will be defined in more detail, include the following: type, size, shape, bulk density, abrasiveness, agglomerativeness, fibrous, hygroscopicity, and chemical composition. First, let's discuss dust size. Size and shape of the particulate will dictate how a dust cake forms on the outside of the filter media. Dust size is expressed in microns, a metric unit of length measurement. An example of a micron is a particle of cigarette smoke.
This graphic may help visualize the size of a micron. The scale on the graphic is 2,000 times normal size. The large circle represents the human hair with a diameter of 35/10,000ths of an inch. The large solid circle represents 1/1000th of an inch. The next large circle represents 1/10,000th of an inch. And finally, the smallest solid circle represents a micron, which is 39/1 millionth of an inch. Here's another helpful analogy. If an NBA basketball is 10 micron, then a PGA golf ball is 2 micron.
Another important factor is dust shape. Shape of particles will dictate how a dust cake forms on the outside of the filter media.
This photo is of metallizing fume, which is a spherical dust. Note the uniform size and shape of the particles. This type of dust can pack very tightly when it forms a dust cake and can be difficult to clean off the filter media. Also, because of the size and shape, this type of particulate will tend to move into the depth of the filter media, plugging pores and causing a higher pressure drop across the filter media.
This photo shows a granular type of particulate. Note the irregular size and shape. This type of dust forms a loose dust cake, making it fairly easy to filter. Also, note the sharp edges of the particulate. This is an indication that it may be abrasive.
This photo shows fibrous particulate from a fiberglass sanding and grinding operation. Note the splintered look of the dust. This causes the material to hold together or be agglomerative. With fibrous dust, extra care needs to be taken in the collector designed to keep the dust from bridging over the outlet and in between the filters.
Other dust characteristics to consider are
chemical composition. Some contaminants contain chemicals that affect dust cake behavior.
bulk density. This measures the weight of the dust by specific volume.
Hygroscopic. This absorbs moisture from the air.
Agglomerative. This occurs when the particulate forms or collects into a rounded mass.
Abrasive. This occurs when the dust is rough or harsh. There are many dust collection companies out there. Why would a person choose Donaldson Torrid?
When it comes to industrial air filtration, Donaldson Torrid has exactly what you need.
Donaldson Company has many of the same loyal customers today as they did when the company was founded in 1915. Because of our long-standing history, we are experienced and can provide success stories in most any industry and application.
Donaldson Torrid provides the highest level of service. We stand by our products, share our expertise, and treat our customers with utmost respect.
Donaldson Torrid can ship most replacement filters within 24 hours, minimizing downtime for our customers.
Donaldson Torrid manufactures a quality product our customers can depend on. In addition to offering the broadest product portfolio in the industry, we also offer customizable configurations when required by our customers.
Donaldson Torrid, exactly what you need.